I ran out of space on my mobile camera, so I'll just wind up. This will take only a minute, but after all the hard work, I didn't want to leave this unaddressed. So we were talking about why this whole method that we did is called the least square approximation method. This is my theory. Now, if we had the values of these two vectors, right, B and P, and if we wanted to find the projection, actually, let me not even say that, okay? If we had this line in terms of we knew its equation, then I already showed you, the formula with dot products, etc. These are the things we dealt with, which will help you find the projection here. So you get the projection, and then you already have this vector. So this is the least distance between this vector and this line, right? And it hits the orthogonal, I don't want to call it perpendicular, but this is where it is orthogonal. So the value of this vector, we have been talking of this as B minus P, can be calculated as B1 minus P1, B2 minus P2, B3 minus P3. And then, what is the shortest distance? It is the length of this vector, okay? And the length of this vector, I am really running out of pens here. The length of this vector is the square root of B1 minus P1 square plus B2 minus P2 square plus B3 minus P3 square. And since we are looking for the shortest distance, the least square approximation term just fits here, okay? And normally a lot of people, I think, just keep on talking in terms of the square to avoid this ghastly sign, but it is still squares, and since this is the smallest distance between this line and this vector, and hence I think the term least square approximation. So we call it the least square approximation, but you can only use it if you know these two vectors. And as I said earlier, I took pains to explain that you can only find this vector using the formula such as, if you remember, I used a formula where you had a dot product, another dot product on top, and the unit vector. This is a unit vector. You can do all of this if you know these two vectors, okay? And here we were fortunate to find this vector by finding the projection here, because this null space was a line, okay? In the case of a plane, so I have my doubts. So you know what, maybe we should run an example where the null space will not be a line. Yeah, I think we should do that. But for now I am really tired, and I hope there was some worth to this video.